Hi, this is Mike Walsh from NetApp, and today I'm going to talk a little bit about remote work and virtual desktops in our new reality brought on by COVID-19. So I think all of us can agree that as we've gone through 6 or 8 months of a changed work environment, the need for remote work is going to exist well into 2021, maybe even further than that. So we, as IT professionals, have to take a look at how we support this change in work mode over a much longer period of time. I think there's a couple of attributes that are going to drive some of that decision making. The first is that we are going to experience periods where situations will change quickly, and scale and variability of where people work and when they work is going to change along with it. And as we look to try and support that with virtual desktops, we're going to have to be able to scale the IT environment to allow for some of that change and for some of that uncertainty as we look forward. The one thing that we can count on is that the locations that people are working from are going to be more varied, as well as the dependency on multiple locations being part of a traditional workspace or replacing a traditional workspace is going to be with us for a while. So the promise of virtual desktops to answer that remote work need is pretty high. We have the desire to have employees work from home, work from other locations, or work from maybe a office setting that's been spread out or had its configuration changed to support things like social distancing. So the virtual desktop mode allows us to answer most of those requirements, but the reality of deploying a virtual desktop environment, especially at large scale or in a variable scale mode, are still very real. A couple of those that we tend to focus on. If you have to do physical deployment on devices and data center elements that you own, then the procurement process for a lot of that equipment is taking a longer time than it used to. So scaling up with your own components can sometimes been challenging. Also, the corresponding challenge for that is that there's additional cost that has to be allocated to support all those component purchases. And that time frame may not be something that matches up with the length of time that we're going to have extended remote work. In other words, if we have to lease the equipment for 3 years, for example, we may not be running that many virtual desktops in the future, and making that expenditure, that commitment of funds may not be appropriate. The other part of it is more logistical, deploying the mechanisms for supporting virtual desktops, taking into account all the different use cases for different application stacks. Again, where the users are working from, are users going to be pretty much fixed like they are today, or with the uptick in travel, will they be moving around the world? How do we get it so that we can support all the different places that they need to work from? And then when we look at the staffing and the expertise, this didn't, remote work and virtual desktops wasn't as important to many organizations as it is today. So trying to get those organizations skilled up in time for supporting, again, this variable scale of employees and contractors that might be working remotely is definitely a challenge for both the IT department, but for HR as well. The last piece I've mentioned on the challenge part is that there can be complexity, because if you think about it, with virtual desktops, we're touching a lot of different parts of the IT footprint. So the users obviously need to be authenticated, so that identity has to be managed somewhere. We need to manage authentication in a very safe way, so things like multi-factor authentication. And the applications are going to be different. The accounting group obviously has a different set of applications than the engineering group or maybe the factory floor. So we do have to account for the variability that the application stack may present. And then we have to touch a number of parts of the internal infrastructure. How are we going to manage the permissions and the policies on those machines? Are they going to be joined to Active Directory that exists, or are they going to be joined to Active Directory that's focused on just cloud implementations? Which the storage layer should we use to store things like user profiles, application data? How do we get access to major applications that have backend database components? So we do touch a number of areas in the IT infrastructure side as well. And if that's a cloud implementation that you're looking at, then obviously the raw services behind some of those IT or infrastructure as a service components do factor into the end user environment as we support virtual desktops. Regardless of the complexity and the variability of the deploy, there are some common characteristics that we should consider when going ahead with a virtual desktop deployment. The first and probably the most foremost thing to consider is security. By definition, the employers are going to be working somewhere other than where their desktop sessions are going to be running. And as we communicate back and forth to that location, we have to be aware that a lot of that traffic is going over the public internet. So we have to make sure that the communications channels, the authentication, all of that is secured against malware and bad actors who will be looking for any vulnerability in the configuration or for the public endpoints, the protection of those, the firewalls, that type of thing. We need to be aware that there are people out there taking names and tracking and mapping places to attack in the future if we're not careful with a solid security deployment. The second is this concept of access from anywhere, and truly we're taxing that particular objective. We need to be aware that things like the internet connectivity between the physical device and say the cloud implementation on the virtual desktop, as well as what types of devices can we run against? Is it just a Windows-based laptop or PC? Or is it a Mac? Maybe it's your mobile phone running iOS, Android, something like that. Or maybe it's just from a browser. We want to be able to give access or even lightweight access for those who don't have a fully featured physical device. Perhaps a browser is appropriate for the applications that they need. So access from anywhere is a goal from the network connectivity point of view, also from the device point of view. And then maybe the third characteristic to think of when we're talking about anywhere, is it something where we have to worry about spread out users at home, which I think is pretty typical in these times, but also large concentrations of users. If we have 300 or 400 users all accessing the same virtual desktop, but that happens to be in a different part, maybe a cloud area, then we have to make sure that the network is capable of handling that traffic as well. I think the cost efficiency factor wasn't as big of a deal in the spring of 2020, but now a lot of organizations are looking at their budgeting for 2021 and determining that the emergency deployments that we did 6 months ago are probably not going to be cost efficient going forward for the long term. So people are taking a step back and looking at that as a characteristic to evaluate. I think we talked about the top about flexibility and scalability. It might be 10% of our employees, 50% of our employees, 75% of our employees that will be using virtual desktops to conduct remote work. And the solution should scale up and down. A lot of times we focus on scaling up. How do I make it bigger? How do I handle more users? But at the same time, I think we have to plan for times when we may not have everybody working from a remote area and we can go back to some of the physical locations. We have to be able to scale back down at that point. Probably the last piece is the one that's most for most users, it's something that we can tell right away is, do we have an end user experience from their virtual desktop that is comparable to their physical device, still provides them access to the applications they need and fits into the security structure we talked about at the top. So I just wanted to touch on a couple of things we've learned over the last 6 months to a year about virtual desktop deployments, especially virtual desktop deployments in the cloud. And what are the elements that support all the characteristics we just went over in terms of common need, but also where's the variability when it comes to performance and capability, and then finally efficiency. Can we provide all these services with the correct amount of resources at the correct price? So the first element I'd touch on is data drives performance. And by this, I mean that in a lot of cases, the virtual machines are pretty predictable in their performance. The session servers that host the virtual desktops typically are something we can size up and down in the public clouds with a lot of variability and a lot of choice when we try and match different use cases. So for instance, if it's typically a worker that works with SaaS applications primarily, or maybe has lightweight office productivity products, email, Word, that type of thing, we can size the machine correctly for them. Well, at the end of the spectrum, if we need graphics heavy applications, design, engineering applications, then perhaps a machine with a GPU enabled makes more sense for that. But the nice thing about virtual desktop software, especially when we talk about Windows Virtual Desktop from Microsoft, we can vary the capability of the machines in the host pools to match those different use cases. I think the tougher part, though, is that when we start talking about the other parts of the performance equation, We don't typically focus enough on the data side because we do rely on the persistent nature of end user data to drive that virtual desktop experience. We need to make sure that we consider a couple elements of that. So the first is that we need guaranteed data transfer rates that are appropriate for pulling the data up in the morning when we start the sessions, and then saving and writing it back when users make changes, or at the end of the day when their user profiles are being put back on the persistent storage. So you want to make sure that you have the correct size and capacity of the storage, but also that it has throughput capability for what you're trying to do. Second element is that invariably, this has been a rule for virtual desktops for a while, but keeping the data and the applications close to the user means that the performance is going to be much more predictable. So if we have our virtual desktop servers in Colorado, but we're putting all of our data on the East Coast of the United States or maybe in Europe, that difficulty makes it difficult for those two elements to be high performing if they're spread out. So we want to try and keep the data elements and the data storage layer as close to the virtual desktop applications as we can. The final piece of this is that when you're looking for the data beyond just the performance characteristics, we also have to take into account things that we would do on-prem as well. So data protection in terms of backup and data and disaster recovery, the ability to comply with any compliance requirements, keeping track of sensitive information, social security numbers, bank accounts, credit card numbers, that type of thing. We may need to add those elements to a cloud-based data solution for virtual desktop, just as we would if we were dealing with an application layer or an on-prem situation. The last piece is we should account for growth. As we talked about at the top, there may be more users using this solution next year than they were this year, and data for end users tends to grow over time, so make sure we account for the ability to dynamically resize the data layer if we need to. The other element that we're seeing is that traditionally virtual desktops have been relatively static in their configuration. The whole goal is to get the virtual machines, the data layer, the networking, then the connectivity from the outside world, get all those pieces stood up, and then we call it done, and we're happy with the configuration as the users log in and use it for meaningful work. The reality for public cloud, though, is that's not the most efficient way of doing things. It has the capability to scale up and scale down, as we see with all the public clouds, Azure, GCP, and AWS, but we're not really taking advantage of that with a lot of our virtual desktop solutions. So for instance, if the virtual machines aren't being used at 2 in the morning, we should be turning those off, not only for the cost savings, but also for creating a smaller security surface for attacks, right? If the machine's not on, it can't be attacked. So we have to consider turning the machines up and down, but also when possible, we should look at how we're purchasing those machines. Pay-as-you-go is a great model because it allows us to turn things up and down instantly, but we pay the retail price for that. Maybe sometimes some reserved instances or 1 to 3 year contract instances make sense for machines that are going to be on a long time. There are also probably some use cases for spot or preemptible type instances where we pay a much reduced fee knowing that that machine could be turned off and with relatively short notice. So mixing and matching those purchase types as well as turning the machines on and off is probably the smartest way to make your compute dynamic as we support the virtual desktops in the cloud, which translates into the best cost efficiency. Same thing applies to the data layer. When we have very active periods, typically at the beginning of a workday, the end of a workday, or beginning of a shift and ending of a shift, we want to make sure that we have enough capacity and throughput to handle the demand. But again, if it's something where at night or over the weekends we don't need all that capacity and throughput, then we can turn those solutions back down on the data side. So again, we're trying to save money from that piece. As a general rule, I would consider doing your architecture along the lines of thinking about plan for burst and plan for disaster. The first one's pretty easy to understand. If we have a given number of users, maybe it's 500, maybe it's 1,000, but we might need to burst to 1,500 to 2,000. Look at your architecture and look at the tool set you're using to determine if it can burst very quickly with minimal overhead. Then we can run in a smaller steady state and not have to over provision and then turn those machines off. So we want to try and make sure that we can handle the demand and know what it takes to burst to the next level without actually having to provision all those components. Same thing applies for locations, right? If you have several large locations and a couple small ones, architect your solution so that when you're looking at virtual desktops, does it make sense to centralize those in the larger locations, or do we disperse those across the variety of locations? It really comes down to what the configuration is for the company, but it is a design consideration up front. Then plan for disaster. When we have the clouds to work with, they have different regions and the capability to replicate data relatively quickly. So we have the capability built into the clouds that allows us to take a set of running virtual desktops in one region and have it turn those down or have them disconnect because of maybe a natural disaster. We can switch over to a more distant location, but with the same capability, same application, and with either real-time data or near real-time data replication, we can start working on the data as if nothing happened. So depending on the resiliency you need for your business, it does make sense to take advantage of the regional nature of the public clouds to do that piece. Last factor on the dynamic part, these static configurations I've talked about tend to grow over time and change over time. So use monitoring data, who's logging in, how many users, what's the resource consumption in terms of CPU, GPU, and RAM, and then disk space, and change your configuration to fit the reality of today as opposed to what it was built for originally or what it was 6 months ago. With the capability of the clouds giving us these services that can be expanded very rapidly without having to wait for equipment to show up, take advantage of that and have a plan for reevaluating your environment on a regular basis. One last slide to talk about. I talked about some of the criteria and design considerations. Just wanted to mention our NetApp virtual desktop service. We do all of the automation components for all the requirements and considerations we talked about in the previous slides. And we take advantage of a number of the NetApp products to do that. So the virtual desktop service is the overall orchestration and management capability for virtual desktops, but it also has the capability to bring to bear a number of the other products you see here on the screen. So for example, the backing data layer for virtual desktop service is typically either Azure NetApp Files in Microsoft or Cloud Volume Service and Cloud Volumes ONTAP in AWS and GCP. For the ability to move data and user profiles around, we use the Global File Cache product. It has a very efficient mechanism for caching SMB data between a core and any remote location. So if you have users that are moving between physical locations, Global File Cache can help move their profile without any interaction from either the user or the administrator to make that happen. Then on the left-hand side of the scene, we talked about some of the compliance and protection. So SaaS backup, cloud backup service, and cloud compliance are all additive to the NetApp data layers and allows us to take the virtual desktop data that's persistent, so applications, users, personal files and folders, as well as their cloud-based stuff. So Office 365, OneDrive, Outlook, Teams conversations. We do have the capability to back all of those up and get the ability to recover those to a specific date and time or pull specific files back from the backups. In addition to all the information that we can protect, Cloud Insights gives us that monitoring tool for evaluating the environment, both for long-term growth and changes that we might need for the configuration, but also as a troubleshooting tool. If we have issues with specific session hosts, we can evaluate what their CPU and RAM consumption is, what the user latency is reporting back in terms of what the user is perceiving from their end user session. We collect from a large number of data points from the public clouds. Azure, GCP, AWS all have APIs. The VDS API provides context in terms of sessions, applications, users, that type of thing. Also allows us to go onto the machine themselves and pull any of the perfmon data that's available from those. So we have a capability to get a very good snapshot as well as good trending information for the whole environment. The last piece I'll talk about is one of the more challenging pieces of virtual desktops is getting the user data that lives somewhere else up into the virtual desktops. And the Cloud Sync product tends to allow us to do that very quickly and efficiently and gives us the capability to shorten the time it takes to move users from their existing environment up to the new virtual desktop environment. Also allows us to move data around if we need to for hybrid environments where you may be keeping some things on-prem or in a traditional private data center, as well as working in the public cloud. I'd like to thank you for your attention today. If you wanted more information on the NetApp product line for supporting virtual desktops, you can go to cloud.netapp.com, virtual-desktop-service. Thank you.